Welcome to EDU World Space.
We're given a system that consists of a vehicle down here that's on a ramp that makes an angle of theta with the horizontal, and then there's a pulley here. Its center is attached to the vehicle. There's a cable that goes around it. One end of the cable is attached to ground, and the other end of the cable is attached to another pulley that's up here. And this is kind of a double pulley that has an inner radius of r and an outer radius of little r. So the inner pulley radius is r, and the outer pulley radius is 3r. And then there's a cable attached to the outer pulley that then has a weight hanging on it, or mass hanging on it, so that we want to figure out how much mass needs to be here to keep this truck over here from falling down. And so a free body diagram of the truck basically says that we have its weight acting down, a normal force acting to support it on the ramp, and then some component up here that is acting to pull down wants to make it roll down the ramp, but we want to prevent it by having this counterweight. We're told that the mass of the vehicle is 1,500 kilograms, and this angle is 45 degrees. So we can just start writing some things down that we know, start writing equations from our picture here. Well, we know F1 is little mg, okay, because that's the weight that we're acting on it. We know F2 and F3 are equal because it's the same cable that is wrapping around this pulley. We know F4 must equal F2 plus F3, okay, for this pulley to be in equilibrium. Likewise, F2 and F3 have to be equal just because for rotational equilibrium of this pulley also. And so since F2 and F3 are equal, then F4 equals 2F3. Now F4 also equals, if we just do some vector components here, figure out the component along this direction of the weight, and that is capital Mg sine theta is F4, to keep this in equilibrium in this direction. And then F3, that means that we can plug in, we can solve for F3, since we know F4, F3 is capital Mg over 2 sine of theta. Now we can take moments about the center of this pulley here, and that says that F2, again, if counterclockwise is positive, F2 times R minus F1 times 3R has to be 0. So that says that F2 must be 3F1. F2 is also F3. So that tells us that F1, let's see here, F1 is mg, but it's also 1/3 F3, which we have here. So F1 is capital Mg over 6 sine of theta and also equals mg. Our g's cancel out, and we get that little m is capital M over 6 times sine of theta, or 177 kilograms.